Hi guys, today we want to find the integral of this such problem. Try to pause the video, have a go on it and see how far can you go. So assuming that you have paused the video, we have this problem. It looks somehow kind of hard because it's like e to the negative x squared, which we know that it's not integrable. So it's not a smart idea to try to integrate what's inside this one. What else can we see is that there is a limit to the left hand side. So maybe somehow we can write this thing and use the limits in our advantage. We can see that this thing can be written as the integral from 0 to the h e to the negative x squared dx minus the integral from 0 to 0 e to the negative x squared dx. Since the integral from 0 to 0 of e to the x squared of any function is equal to 0. So this is just, we added some 0 in a fancy way, which is the integral from 0 to 0 e to the negative x squared dx, and we take the limit when h goes to 0 of 1 over h. This doesn't look that much of easier. However, if we define a function, let's call it g of w to be the integral from 0 to w of e to the negative x squared dx. So let's define this as a function. So we define this new function. So the given thing, or the thing in the right hand side, will become the limit when h goes to 0 of 1 over h g of h minus g of 0, because the value in the second one will be equal to 0, which is this one, so this one 0. And this one looks kind of familiar. This is just the derivative of g with respect to w. So this thing is g dg dw, because this is because this is derivative. So this thing is g dg dw. If we go to the function and we want to differentiate with respect to w, this thing will be equal to e to the negative w squared. This is thing evaluated at the value is equal to 0. So we have to evaluate this thing at the value equal to 0, because this thing is 0 here. So the final answer would be e to the negative 0 squared, which is just 1.